Hello friends, I hope you have been keeping pace with the numericals that we have done so far. Next in that series, remember we have finished altimeter, airspeed indicator and Mach meter. We have done some of the most common questions generally asked. Now today we will cover numericals asked in your gyro instruments. Gyro instruments, generally the questions are asked in directional gyro indicator, DGI or DI, and in a turn coordinator or turn and slip indicator. What are the types of questions asked? Let us understand. If we start with the directional gyro first, a directional gyro is an instrument to give us direction. Why do we need another instrument when we have a magnetic compass already with us? Directional gyro gives us the readings from the gyro north, which can be reset by the pilot. If you align your gyro north with the magnetic north, it will behave like a magnetic compass. And in some ways, it is better than magnetic compass since there is no dip. It has no turning and acceleration errors. But yes, it has its own problems. And one of the common problems is the gyro drift or gyro topple. The gyro axis points towards a point in space, whereas magnetic compass points to the magnetic north. Now, if we have started from here, this is the point, and you are stationary over this point, that is flying over the same point, and that is called a stationary gyro. And you have a certain direction of the aircraft. Okay. And at this time, your gyro north and magnetic north are same. So you will get the same reading on your gyro as well as on magnetic compass. Gyro and magnetic north are the same. But over a period of time, the Earth will rotate, and rotation of the Earth is each meridian rotates at the rate of 15.0 degrees per hour, completes full 360 degrees in 24 hours. For our numericals, we take a value of 15 degrees per hour. After some time, even if the gyro is over the same place, has not moved at all. Now, this is the aircraft at the moment pointing in this direction. The gyro is still pointing towards the same north. Draw a parallel line, which is that point in space. Whereas this meridian is now at the time pointing in this direction. That is my magnetic north. So my magnetic compass will give me this direction, call it angle A, whereas my gyro will give me this direction, call it angle B. In other words, we will see that the gyro readings has decreased. This is the, I repeat, this is the reading from the magnetic north, whereas this is the reading from gyro north. So magnetic compass reading, that is A, will be more and gyro reading B will be less. Or we can say even in a stationary gyro, Due to gyro drift, also called apparent wander due to Earth rotation in a stationary aircraft, means over the same place. In the northern hemisphere, readings will decrease. In southern hemisphere, readings will decrease. This is what will happen in the southern hemisphere. When you started from here, you aligned your magnetic compass and gyro north and magnetic north in the same direction. And this aircraft will give you same direction on both. After some time, this aircraft has now over the same meridian, but the meridian has moved. Now this will be the magnetic north and this will be the gyro north. So gyro reading will be more than the magnetic compass reading, and we will say gyro readings will in the southern hemisphere increase. What is the rate of increase or decrease? It is the called gyro drift or wander, and this is apparent wander. 15 degrees into sine of the latitude and per hour. In 6 hours, the same latitude where I was will move by 90 degrees. In 12 hours, 180 degrees. And in 24 hours, 360 degrees. And this meridian will be back to the same place. So because of rotation of the Earth and because of apparent wander, the gyro readings in the northern hemisphere decrease with time, southern hemisphere increase with time. Now, you would have understood the reason if you have started flying, why your instructor tells you to keep realigning your gyro every 15 minutes. That is to eliminate the apparent wander. But is it necessary to do it every 15 minutes? Maybe not. We'll see it later. Why not? If the aircraft is also traveling towards east, it's not stationary, the aircraft is also traveling in the east direction. Now, there will be wander due to this meridian having moved east, and aircraft has moved further east. So gyro readings will decrease at a higher rate. In the southern hemisphere, they will increase at a higher rate. What will be the addition? That is called the vehicle wander, movement of the vehicle in the direction east. If the aircraft is moving west, gyro readings will decrease, but at a lesser rate. You are traveling west, but the meridian is traveling east. So gyro readings will decrease, but at a lower rate. And the southern hemisphere, they will increase, but at a lower rate. What if you are traveling north? In the northern hemisphere, gyro readings will decrease and at a higher rate, because as you are traveling north in the northern hemisphere, your latitude is increasing and this value, sine latitude, is increasing. But in the northern hemisphere, but if you are traveling south, aircraft is traveling south, gyro readings will decrease, but at a lesser rate because the latitude is decreasing. If you're traveling in the direction south, when you are in the direction south in the northern hemisphere, this is the aircraft traveling south in the northern hemisphere, readings will decrease, but at a lower rate since latitude is decreasing. And if you are traveling north, readings will increase. If you are southern hemisphere and traveling north, readings will increase, but at a lesser rate because you're south of equator and now your latitude is decreasing. Now, if you are traveling in the direction south, in the northern hemisphere, readings will decrease, but at a lesser rate. In the southern hemisphere, readings will increase and at a higher rate because your latitude is increasing. There are generally not too many questions asked on topple. Topple is the wander of the gyro axis in vertical plane, and drift is the gyro axis wander in horizontal plane, and the direction is measured in horizontal plane. So these are the questions often asked. Will the readings increase or decrease if you're traveling north, south, and if it's a stationary gyro? So this summary, I hope, will be able to help you. Next is there a need to really set it at every 15 minutes, reset your gyro? Maybe not. Stand by a little bit. Let me rub it off and I'll be back with you. Prepare the next slide for you. Fine. Let's say I'm flying at 30 degrees north. So first step will be write down a apparent wander due to Earth rotation, and the aircraft is at 30 degrees north, will be equal to 15 into sine 30. That will be 7.5 degrees. If you are in the northern hemisphere, write down readings will decrease. If you are in the southern hemisphere, write down readings will increase. That is a normal gyro. There is a device known as a latitude nut, which physically creates real wander and moves the gyro axis physically, and it can be used to correct the apparent wander. If I set my latitude nut also to 30 degrees north, it will create a real wander whose value will be 15 into sine of 30, that is 7.5 degrees. And if I set it to north, it will, the readings are decreasing at the moment, northern hemisphere. It will increase the readings in the northern hemisphere, and my net wander will be 0. So if I'm flying at 30 degrees north and I have set the latitude nut, this will be called as a gyro balanced at 30 degrees north or compensated at 30 degrees north. If your latitude is same where you are flying and you set the same latitude north, then your net wander will be 0. You can fly over this latitude without resetting your gyro. But there's a problem. If you set the latitude nut to 30 degrees north, but you take the aircraft now to 40 degrees north aeroplane and start flying over there, This gyro has been balanced at 30 degrees north. So what will happen now? My latitude knot will create a real wonder and give me 7.5 degrees increase in gyro readings by moving the gyro axis anti-clockwise. But if I now take my aircraft to 45 degrees north when I'm flying here, now my wonder will be 15 into sine of 45, which is 0.71. And my wonder will be now 10.65 degrees, 15 into sine 30, which is 0.71, is equal to 10.65 degrees. So now what will happen? My gyro readings will decrease by 10.65 degrees. Now, what will be the net result? Since decrease is more, I will write down here my gyro readings will decrease. How much this difference? 3.15 degrees. And remember, it is per hour. These readings are all per hour. If it is 2 hours, multiplied by 2, 2.5 hours, multiplied by 2.5, and that will be the total wonder created. What will happen? Another case, I am flying at 45 degrees north, but this gentleman who set your gyro may be not well educated, not well trained, and he has set the latitude not to 45 degrees but south. Now there's going to be a problem. What is the problem now? My gyro readings were decreasing at 10.65. Latitude nut is set to now 45 degrees south, which will create a wonder of 10.65 degrees. And since I have set it to south, in the south, normally the readings increase. So it will decrease the readings. Now what will happen? Instead of 10.65 degrees, which would have happened in a uncompensated gyro, a gyro which has been compensated for different hemisphere, it will also decrease the reading, and my total decrease will now be 21.3 degrees decrease and per hour. So I hope it is clear that your latitude nut works for a given latitude at which you have balanced it. So if your aircraft keeps flying at the same parallel local flying area every day, no problem, set your latitude nut, and then there is no requirement for you to reset your gyro every 15 minutes because the job will be done by the latitude nut by creating a real wonder. If the readings are the northern hemisphere decreasing, it will move the latitude nut, it will move the gyro axis anti-clockwise. If your reference point moves anti-clockwise, your readings will increase. And vice versa in southern hemisphere. Okay. So that is the functioning or the questions often asked in directional gyro indicator. Now let me give you a question for your homework. aircraft is flying at 30 degrees north. Aircraft is at 30 degrees north. And we just calculated the gyro wonder should have been 7.5 degrees per hour and decrease. B is latitude nut setting. C is net wonder. That is the resultant of these two readings. If both these readings are decrease, add them up. If one is decrease and one is increase, then find out the difference, and whichever is more, write down. That is what will happen. For example, if latitude nut is giving you 10.5 degrees increase instead of 7.5 degrees, now you'll have an increase of 3 degrees per hour because the increase is more than the decrease. If this is also decrease, add them up, it will become 18 degrees per hour. Third is the type of the questions which says that after having set your latitude nut, there is a decrease of 4 degrees per hour. Gyro readings are decreasing by 4 degrees per hour. Now, what has happened? You have not set the latitude nut to correct place, and therefore it is only increasing your readings by 3.5 degrees per hour. Increase means its set has been set to northern hemisphere, but which latitude? 15 into sine of which latitude will give you 3.5, and that will be the latitude where you have set your latitude nut. So out of A, B, and C, if two are known, third can be calculated. Remember, in the northern hemisphere, gyro readings decreases. Latitude set to northern hemisphere will increase the readings. In the southern hemisphere, readings will decrease. Gyro readings will increase, and latitude nut will decrease them. And net wonder is the resultant of these two readings. Then there are questions asked in turn and slip indicator or turn coordinator. The turn coordinator or a turn and slip indicator gives you a rate of turn. A standard turn coordinator gives only rate 1. Turn and slip indicators can give rate 1, 2, 3 also. There are different types of instruments available. See the one fitted in your aircraft. Rate of turn is degrees per minute. If your aircraft is turning 180 degrees per minute, it is called rate 1. 100 degrees per minute will be equal to 3 degrees per second. If you are turning 90 degrees per minute, it will be called rate half. And rate 1 turn is also known as standard turn. Rate 2 will be half will be 1.5 degrees per second. Rate 2 will be 6 degrees per second, etc., etc. Then the question can be asked that, okay, you are facing in this direction now, let us say 040. Aircraft turns on to 130. So calculate it is 90 degrees. So he can ask you that if you have taken 60 seconds, what is your rate of turn? 90 degrees divided by the time 60 seconds comes to 1.5 degrees per second. Tell him I'm turning at rate half. If takes you 30 seconds, you are turning 3 degrees per second. Tell him that I'm turning at rate 1. Or he may ask you the other way around, that this is your direction 0, 6, 0. You are turning left at rate 1 for 40 seconds. In which direction will the aircraft roll out? If you are turning at rate 1 for 40 seconds, 40 into 3 degrees per second, you will turn by 120 degrees. 120 degrees to left means 060 can also be written as 420 degrees. When you are turning left, readings will decrease, and tell him I will roll out on 300 degrees. These are the types of questions which may be asked to you in the numericals. Okay. He can ask you the rate of turn. He can give you the rate of turn and ask you how many degrees the aircraft has turned in so many seconds. Or he can tell you have started from this point and turning left or right, what will be your rollout direction? Point to remember is that when you are turning right, your direction will increase. Now, what is the normal method? If you have to turn right by more than 180 degrees, let us say, in a standard normal method, what we'll do is that you are on 070 and it says turn right by 190 degrees. Unless he says that turn right, normally what I'll do is I will turn left by 170 degrees. But if he says turn right, now I have no choice, I will turn right. Then now my readings will increase. 70 plus 90 is 260. So 260 degrees is the direction of rollout. And this is my turn of 190 degrees. If I had turned left, I would have turned by 170 degrees. If you have no choice, follow the directions. And now he could ask you that if you are turning at rate 2, how many seconds will you require? Rate 2 is 6 degrees per second. So divided by 6. So roughly 32 seconds. 6 3s are 18, 1 10, 32 seconds. So these are the questions, type of questions which you may be asked in the examination on turn and slip indicators. There could also be questions in the theory regarding your radius of turn, rate of turn. If remember, if your radius increases, rate will decrease, etc. Those are generally theory questions which are covered in the theory lessons in a turn and slip indicator, that if you change your speed, what will happen to this thing? Okay, rate of turn, speed, these are variables during a turn. And then there are questions asked. If you want to maintain a rate of turn, what should you do with the speed? If your theta bank angle has changed. So those are the type of questions asked in theory. Theta. Okay. Now your theta is directly proportional to the speed, true wave speed. And theta is inversely proportional to the rate. I beg your pardon, rate of turn. If your bank angle is same and you will have a certain rate of turn, if you decrease your speed, radius will decrease, rate of turn will increase. Similarly, if this is your bank angle, this is called the radius. If your speed increases, radius will also increase, then rate of turn will decrease. So speed, radius of turn, rate of turn, and the bank angle are also interrelated, and there may be some questions on that. Although these are not in the terms of numericals, they are conceptual questions. So if you increase your theta, keeping your V constant, your radius will decrease, bank angle, radius will decrease, and your rate of turn will increase. Theta numerically is V square by G into R. R is the radius. Theta is directly proportional to V. Higher the speed, higher should be the angle of bank to maintain. G is a constant to maintain the same radius, and radius is inversely proportional to the rate of turn. So if you increase the theta, radius will decrease at the same speed. Radius will decrease, rate of turn will increase. Okay. And I think here I can recollect, although I told you, maybe I told you, theta is inversely proportional to rate of turn. Theta is directly proportional to speed. Higher the speed, higher is the bank angle required. And higher the theta, lesser will be the radius. And if lesser the radius, more will be the rate of turn. While speaking, I think I recollect, maybe here I made a mistake. You can correct it now. Instead of recording the whole session, please note this correction. And good luck. All the best. Till we meet again for the next session. This is SK Booty signing off for the day.